good. So, hello everybody. Today, on the challenge provided by the Arctic Hackathon, we will display our challenge, which was regarding the operator information. Moving forward with the problem statement, in a city that becomes more and more connected with IoT devices, how can we offer a platform or a visualization for an operator to take informed decisions about outages in the city and information regarding those sensors present in the home systems? Because current systems do not effectively integrate environmental operations, the energy usage of data, or it cannot predict or alert about anomalies. Moving forward, it's very important to discuss about our solution that we found and we tried to implement in this hackathon, where we try to create a visualization of a map regarding actual map locations in order to be able to highlight specific houses in case of outages, and of course alert the operators through some visual cue if problems are available at that location. Nonetheless, we want to go a bit more in depth with the admin dashboard that we created. This offers us access in the backend regarding the data information in case, for example, we want to reset the database in case we find the IoT sensor faulty, or we just want to integrate new sensors seamlessly. Lastly, on my end, I would like to speak about the display integration that we tried to integrate. Initially, we were trying to map a 3D building on the map, but later decided that we can do it on 2D, but also make it scalable across any housing residence in Skellefteå or in Sweden. So in the end, we had a 2D approach. And on this 2D map, we are implementing a pop-up system to display all the information that I spoke about. The program will overlay this layer and will display all the needed information for the operator.
Okay, so yesterday we talked about how we're achieving this by creating an overlay on top of the OSM layers to display the houses and then highlight information for the houses. So this is kind of the map that we have. So, well, the overlay displays, these are the houses that we have information about, so they're going to be displayed with a dark overlay, and then the houses with anomalies are displayed with a red overlay. Okay, so this is the architecture that we have currently. So we have the front end with the map and the dashboard that the end user can use to see the houses and the maps. And then we have in the back end, we have a Django web server that is running a database, and then the database receives data from sensors from various buildings. So we're assuming that we have installed various sensors in the buildings, and the sensors are all sending data through IoT protocols to the database. Then we are also receiving building information from the internet, so OSM, and we're keeping it in the database. So whenever a user is browsing the map, then we are using the sensor data and the building information to get to provide those highlights and the building data that the user can see. Also, we have an admin page that an admin can use to add new buildings and see the status of the sensors. Okay, so these are some of the metrics that we currently have. So we're using house floors as a description of the building, and then some of the sensor data such as temperature, power consumption, CO2, and the like. So we also provide an API for third-party companies that they can use. They can get the data through our system, if they want to build their own product. And so we do provide APIs to third parties as well. Okay, so this is kind of the card that is used to show the information regarding the building. So we have the sensor data here. So this is a scrollable card that displays information in three tabs, basically. So we have the sensors that is displaying the current sensor information. So we have electricity usage somewhere over here. So if there is an anomaly in one of the sensors, then it's going to turn red. So with the building, so if there's a red building, and then it's going to show what the sensor is an anomaly in here. So it's going to turn red to to allow the operator to know what is going wrong with the building. And then we have the building general information. So we have a generic 3D model of the building. So this is not a real implementation, but we have we have shown how the building looks, and then some information. And then we have the historical sensor data as well to show what the trend of electricity or some of the metrics of the sensors were. Okay, so I would like to call Luke to continue.
Yeah, so how useful would this project be? Well, potentially it could enable first responders to detect hazards. Say if temperature suddenly spikes and there is a metric for CO2 level and that also spikes, we could possibly assume that something's wrong. It can also help municipalities to work on saving energy across multiple buildings and analyze and monitor their buildings' well-being and effectivity. It also allows for quick identification of trends and patterns in both weather and energy usage. It can also provide companies with data to allow future development of other products. And as a business, it does have some potential since it allows customers to monitor and optimize their energy usage, and potentially even other areas could be affected and optimized too. It can also be used to monitor air quality, for example, so that we can easily see when a building needs renovation or new air filters or something of important. And also this monitoring makes it so that we can quickly troubleshoot what is wrong or if something comes up. The product is very scalable and could allow the customer to create their own metrics, as mentioned. Or the customer may already collect metrics, but they maybe don't have any way to summarize it in a nifty or neat way. It could also allow individual customers living in residential areas to monitor their own house at a distance or such. For the future, we would like to integrate existing BIM models to create a 3D map and also get real-time data from real sensors, because right now we are just using generated data. We could also improve the design since this card, it's not very clear that you can scroll vertically, and some minor tweaks on other ends could also be made. And we would also like to integrate email or SMS so that we can more easily see when something goes wrong and more quickly respond to it.
Okay, so I'd like to continue with the demonstration of the application. So this is the main page that we have the map on. So we have this. So the map is going to be constantly getting data from the backend. So it, for demonstration purpose, I've set it really quick to see that changes in the building occur when it gets new data. So new anomalies are going to be occurring in the map. So So you can see that constantly the data is changing, and if new buildings come up with some anomalies such as a spike in electricity, so the map is going to change, and then the buildings are going to get. So if we see one of the cards, you can see that the electricity consumption in here has turned red, because that is something that needs attention from the operator. So we can highlight that in red to show that this current building needs attention from some electricity company. So if the building has a regular operation sensor, so there's nothing to see there. So information regarding the building, and then And then on the last tab we have the historical sensor data as well. So we haven't currently implemented the sensor data with real data, but we can do that. So on the dashboard side, we have the admin dashboard to add the buildings, and then the sensor to monitor everything about the system. So we can add new buildings here. So if we decide to add a new building to the system, then there is a place to add buildings, and then we can also add sensors that are related to the building. So if we decide to add a new sensor to a building, we can do it through here. So we select the building that we created, and then we add a new sensor to the building. And then inside each building we have certain tabs. So there are the sensors related to the building. So there are currently all of these sensors working. So, and we have some metrics, like is the sensor still generating data, so it's active or not, or is the sensor is not responding from a certain time, then we can call it as a dead. So the admin will need to look into replacing the sensors. And then we have a graph as well here to allow the admin to see the trend of the sensors. Okay, so some of the readings we have here. So the readings are going to show up like this in the admin page as well. Yeah. That is the demonstration of our product.
Questions?
One of your teammates. Where is?
Yeah, we're just 3. Sorry? Thank you.
So, thank you very much.
Thank you.
Thank you.